Okay, we've already talked about mean, median, and mode. We've already talked about range. We've talked about the 5-number summary. Now we're going to talk about another measure of spread. Remember, measure of spread is not where is the middle of the data, it's how wide the data is spread out. Is it tightly packed data? Is it large spread out data? Who knows? What we're going to do now is talk about the standard deviation. Now, obviously, deviation is simply the amount of change in something, the change particularly from the expected. And so a standard deviation would be a normal, usual, acceptable, expected measure of change that we would expect to see in a set of data. Because all the pieces of data are somewhat different, the question is what's too different? And we'll talk about that here as we move forward. So to find the standard deviation, there is a formula. That formula is actually the square root of the sum of x minus x bar, the quantity squared, all over n minus 1. And you have to do this. But the easiest way to actually accomplish this task by hand is to make a little chart, kind of a spreadsheet if you will. Now, to finish this, what we're going to do is we're going to take x minus x bar. Now, x bar, if you'll remember, was 63.64. Now, for ease of use in this example, I'm going to approximate this to be 64. Now, to actually get an accurate number, you would need to use 63.64. But so that everything looks a little bit prettier and easier to understand, I'm going to use 64 on this one. Now, so I take 62 minus 64 and I get negative 2. Now this makes sense because negative 2 is going to be, 62 is below the average by how much? By 2. So I take 45 minus 64 and I come up with negative 19. 81 minus 64, I come up with 17. 67 minus 64, come up with 3. 63 minus 64, negative 1. 65 minus 64, 1. 78 minus 64, 14. 71 minus 64, 7. 42 minus 64, negative 18. 42 minus 64. Let's double check that one. For some reason, brain disabled. 42 minus 64. Negative 22. It's a good thing we checked it. Okay. And finally, 65 minus 64 is 1. And 61 minus 64, negative 3. Okay, so we have taken the data value and we've subtracted the average from it. This is the deviation. That is how much each of these numbers is from the average. Now the question is, this deviation is quite a bit different. So what would be, based on our data, an acceptable, standard, or reasonable amount of deviation? That's where we keep going. To do this, we're going to take x minus x bar, we're going to square it. Reason is, some are low, some are high, some are below, some are above, but we're looking for the overall amount of change, not which direction it has changed. So the easiest way to get rid of direction is to square it. So I'm going to come up with 4. Now, 19 squared is going to require a little bit more work. 361. 17 squared, think I know it, but double check, because if one of these numbers is off, then the whole thing is going to be off. You'll notice I'm not even putting in the negative on the 22 because it will go away. Now, that is x minus x bar, the quantity squared. If we look at our formula, we have now done this component right here. The sigma, of course, means sum it up. So I'm going to add all these terms up. Through the use of video magic, I add all these terms up and I come up with 1,404. Now, if we look at our formula again, we see that once we've added them up, we need to divide by n minus 1. Now, n is 11. So, if we take 11 minus 1, I come up with 10. With that, obviously that's going to be 140.4. 140.4. Now, this number here is a very important number. This is called the variance. Again, it's how much it varies. It's the sum total of how much things are varied. The easiest way to explain it is it's the number that leads to the final and important number, which is standard deviation. So if the formula for standard deviation, S, equals the square root of the sum of x minus x bar, the quantity squared, all over n minus 1, that means I have S equals, I have this number here, which is my variance, and I need to square root it. So let's grab it and do it. I have second square root 140.4. Answer is 11.84. S equals 11.84, or approximately 11.8. Now remember, it's not going to be an exact match because I did round my mean, did round my average a little bit to make it easier. But what we're looking for is an approximate expected change of about 11.8. Now, if I did it on computer or used the calculator, I would have actually come up with 11.84, allowing the calculator to do all of my work. So as you can see, I came up with 11.845, 11.8. I'm in the ballpark. This is my standard deviation. For those of you with a calculator, if you will remember, I said you could put the data in as a list. So I have a list, and I can use my calculate button. I'm going to calculate all the statistics for one variable on second, what list, that list that I put in earlier, and there it is. I would come up with an average of 63.63, total sum of 700. I have a standard deviation of 11.84. We'll talk about sigma x in a little bit. You'll also notice I have a min, a Q1, a median, a Q3, and a max. So this gives me all the numbers that we've been finding by hand. But again, we want to understand how we get them by hand so that we know what to do, what the calculator is doing. Another way to think about this formula is the way Mr. Jones does it. It's the square root of adding the observed, the x that we actually found, the observed, minus the expected, because the average would be what you would expect out of a pile of data, divided by the number minus 1. So whether you remember it in terms of words or whether you remember it in terms of symbols, it's still just as effective. Now, you'll remember the 5-number summary and how we used it to make a graphical representation. Same thing happens here. I can make a graphical representation. In the middle, I would expect to find everything that's average. And the average for ours was, we're going to go with 64. Now, at 11.8, I'm going to go with a standard deviation of 12. So my standard deviation, instead of 11.8, let's use 12 again to make it easy. So what I can do is I can go this way, 12 units, which is 76, another 12 units, which is 88, and another 12 units, which is 100. So I did it 1, 2, 3 times. I added 1 standard deviation, 2 standard deviations, 3 standard deviations. Now I can go back the other way as well. Minus 12, I come up with 52. 40 and 28. Now, using that information, I'm subtracting 1 standard deviation, 2 standard deviations, and 3 standard deviations. This gives me my range of values that I would expect. Now, we have what's called the empirical rule. The empirical rule is going to be where we pick this up next.